Right, so today we're looking at solving system of linear equations by elimination. This is another technique in finding the intersection point of two linear equations. The first one was substitution, where I called it a nickname and you plug it into the other equation. This time we're trying to eliminate one of the variable terms to find the other. So let me show you what that looks like. And the same instructions are to solve this, meaning we're trying to find the intersection point. So this time I have x plus 3y equals negative 2. And then I have x minus 3y equals 16. Now, these two equations, you can already tell there is not an isolated variable. There is not one variable by itself on the left side of the equal sign. These are both in standard form. And what does it mean, standard form? Standard form is when you have an equation that's got your x terms, y terms equals your constant, a number. So these are both in standard form. Because they're both in standard form, you notice that your two x terms line up perfectly vertically, your two y terms line up perfectly vertically, and your numbers, constant terms, line up vertically. So we're going to do something that's not usually done. We usually do math horizontally, but this time we're going to total these up vertically, just like you did when you first started adding in elementary school. The numbers are written vertically instead of horizontally. Now, this is called elimination. That means I want to eliminate one of my variables. I cannot draw the line here and solve it. I can't. I cannot get one of them by themselves because there's two. There's an x and a y. I need to focus just on one. So part of this elimination process is you want to get rid of one of the variables so that you could focus on finding the other. And in this case, if I add them up, this would be 2x. If I add this up, that would give me a 0. And if I add these up, that would be 14. So because I can already see that right here, if I do add these up, I'm going to get a 0. That's great because that means I do not have to worry about the y's. And if the y's are all gone, I'll just have x to focus on. So I'm going to do that. And if I add these two, again, I said it was 2x. 1 plus 1 is 2. Plus 0 because that totals 0. And this would be 14. So the elimination process is wanting to get rid of one of those variables. And in this case, my y's are all gone. And so now I'm able to focus on finding that x by doing the inverse operation, which is to divide by 2. That's 1x equals 7. So I am almost halfway done. Well, I am halfway done. I got the x coordinate, which is 7. And now, remember, the problem is we cannot have two variables at the same time when we're trying to solve. But now that I don't have a variable for x, I won't have a variable for x because I can replace it with the 7. I'm going to use this first equation, and since I did have two variables and I wasn't able to solve it, if I replace this with the 7, then I'll only have a y in there. So that's what I'm going to do. So I'm going to replace that x plus 3y equals negative 2. All right, and just so you see where that came from, let's show you that this equation just came down here. Okay. And now my x was 7, so that's what I'm putting here. Okay. I couldn't solve it before because I can't have x and a y, but now that I know x is 7, I don't have an x anymore. I'm able to focus on y. And so I'm going to get rid of 7. Now I just have 3y equals negative 9. And then in doing this, you divide by 3. And we get y equals negative 3. And that's your solution. Okay, So what do? We vertically combined the terms. One of them gave us a 0. And once you get that 0, you do not have your y's anymore, so that you can focus on finding x. Once we found x, we knew that if we replaced this x with the 7, now our equation would only have y's in it. And then now we can focus on finding the y. Okay, so let's try example B. Example B says negative x plus 3y equals 0, and x plus 3y equals 12. And when we're doing the elimination method, you kind of want to know what you're doing before you start writing anything down. So let's focus on this one. Will I get a 0? If I add these up vertically, will I get a 0 somewhere? And if you do, then just go to it and do it. If not, then we're going to have to do something different. And I'll show you what that different one is. Some students will say, yeah, Miss Flores, you got lucky this time, right? 3y minus 3y is 0, but that's not always going to happen. You're not always going to get a term that equals 0. And in that case, we are going to do something different, and we'll get to that. So, for this one, you should have been noticing that if I add them up, these two will be 0. Negative invisible 1 and a positive invisible 1 gives me 0 x's. So in this case, my x's are gone first. Now that I don't have x's anymore, I can focus on finding the y's. Combine these terms together, that's going to be 6y. We're adding them up, okay? Combine these together, that's 12. And now when I'm solving this, divide by 6, and I get y equals 2. And this time I found my y coordinate first. And now that I know that y is equal to 2, I didn't like seeing the y in my equation because it had two variables. But if I can replace it with the 2, I won't get to see y anymore. So let's do that. And let's just pick the first one again. Doesn't matter which one. I'm going to take this one, and we'll use that one. So it'll be negative x plus 3 y equals 0. All right, so now that y, instead of putting a y in there, we're going to put a 2, the one we just found. And by doing that, my equation now only has an x variable, and I can focus on finding it. Before, when it was a y here, I was like, what? I can't do two variables at the same time. All right, now we got 6 here. Negative x equals 0. Now I can get rid of the 6. Addition of 6, subtracting 6. And that's going to be negative 6 on the right side. And bring down this negative x over here. Now, we're not done because that's not x. That's negative x. And I want positive x. So what I got to do is, I know this is an invisible negative 1 being multiplied. So I'm going to divide by negative 1 in the inverse operation. Negative divided by negative is positive x. And negative divided by negative is positive 6. And so that's my solution. 6, 2. All right, so let's look at example 2. What happens when you don't get that initial 0 in the elimination process? And what do you do to fix that problem? So example 2 says, or example 2a, we'll do 2 examples. 3x plus 4y equals negative 6, and 7x plus 4y equals negative 14. So as you're looking at this and you're wanting to use the elimination technique, you can't identify where that 0 is going to be, because this doesn't give you 0. That gives you 8y, and that's not what we're looking for. We're only needing to find zeros on the variable terms. So we got a problem. And to solve that problem, I say we have to make a wish. And I'll show you what I mean. And I'm going to say that I wish this was a 0. Okay? I wish I had a 0 there. Now, but I don't. Now, I need to make that wish come true. So how do I do that? Well, let's identify this as equation 1. And this will be equation 2. We're going to have to change a little bit of the problem. So looking at what I have and what I need, the only way I can get a 0 is if this was actually a positive 4y with a negative 4y. Then I would get a 0. So that's what I wish. I wish I had a positive 4y and a negative 4y. That would be great because I would have a 0. And that's okay. Once you make that wish, we got to make that wish come true. And the way we make that wish come true is mathematically change that equation. So 4y positive, that one's okay. But the second equation has a positive 4y here, but I need the second equation to have a negative 4y. So what can I do to this positive 4y to make it into a negative 4y? And you should have been thinking, I'm going to multiply that by negative 1. So I multiply this term by negative 1. I can't just change one term, I have to change the whole thing. So what you do to one part, you do to the whole thing. So I got to multiply this guy by negative 1 and this term by negative 1. So the entire second equation gets multiplied by negative 1. So now my first term in the second equation would be negative 7x, and this 14 that used to be negative will now be positive. And since nothing needed to change in that first equation, it's going to stay the same. 3x is still there, and negative 6 is still there. Okay, so now I'm ready to add up my two new equations. 3x, take away 7x, is negative 4x. Negative 6 plus 14 gives me 8. Now I only have x's in my equation. Focus on solving for x. Opposite of multiplying by negative 4 was dividing by negative 4. It gives me invisible 1x. And this gives me negative 2. So I just found my x coordinate. And now I need to find my y coordinate. Now I have 4 equations now. 2 here and 2 here. Doesn't matter which ones I choose. I'll just go ahead and go with the first one. Use that one. Initially I couldn't solve it because I had x and y. And I needed to have only one variable in the equation, not 2. But now that I know x is negative 2, I'm going to replace that x with a number so that now I'll just have a y in there. So let's go ahead and do that. 3, a bubble for my x, plus 4y equals negative 6. And so now I knew x is negative 2. My equation becomes negative 6 plus 4y equals negative 6. And now to get rid of that negative 6, I'm going to add 6 to both sides. Now I have 4y equals 0. And then I get y equals 0. And that's my solution. All right? Alright, so let's look at example 2b. And 2b says to solve negative 6x plus 5y equals 25, and negative 2x minus 4y equals 14. right, so now when we're trying to solve this problem, we again want to try to find our 0. And this time, we can't really see a 0 happening anywhere. So now what you want to do is you want to think about what would be your least common multiple, just like we used to think about what would be your least common denominator. So if you want to just think about the terms being your coefficients being your denominator. So if you had a denominator of 6 and 2, just looking at the digits, or a denominator of 5 and 4, what would be your common denominator here? What would be your common denominator here? It's like asking you, what is the least common multiple of 6 and 2? What is the least common multiple of 5 and 4? So if you had to pick, which would be the easier common denominator to find? It should have been this one, right? You would just say, oh, the common denominator is 6. Here, your common denominator would have been 20. So same idea here. I would wish this was a 20 and a negative 20, or I can wish this was a 6 and a negative 6. Okay? So, backtrack. When you're seeing your two sets of coefficients, you want to focus on a least common multiple that you wish you had. And I wish this least common multiple was negative 6x and positive 6x. Okay, so in looking at this, I asked myself, what do I wish I had? What would make it a 0? And when you see a 6 and a 2, just think of when you used to see them as fractions. Oh, I can make them both into 6s. This time, though, to get 0, one has to be negative, one has to be positive. Okay? So again, let's label this first equation. Second equation. This would be my first one and my second one. So now, I wish I had negative 6x and positive 6x. So now I need to make that wish come true. How? This negative 6x is already here in the first equation, so that one's good. But this negative 2 needs to become a positive 6x. What happens to negative 2 that makes it into a positive 6? And that is to multiply it by a negative 3. Negative 2 times negative 3 gives me a positive 6. So that's what I'm going to do here also. Times this by negative 3, and times this term by negative 3. Okay? And now to do that, negative 4 times negative 3 is positive 12. Y. And 14 times negative 3 is negative 42. So that's my new second equation. And the top one didn't change, so we can just go ahead and write 5y equals 25. Okay. Now I have my two equations that I know will give me a 0 for the x term, so I can add them up now. 5y plus 12y is 17y, and 25 minus 42 gives me negative 17. So to get rid of that 17 now and get my y, opposite of multiplying is dividing. And I would get y equals negative 1. Okay? And just like before, I want to replace that negative 1 in a y spot in any of the equations. I'll use the first one again. Just common protocol, I guess. So now I'm going to rewrite it. Negative 6x plus 5, my y that I now know, equals 25. And since I now know my y is negative 1, that goes there. So my equation is now negative 6x minus 5 equals 25. And then gonna Add 5 to both sides to get my x all alone. So it's negative 6x equals 30. And then this is multiplied by negative 6. So I divide by negative 6. And so now x equals negative 5. Okay? So from the top, you had your original equations. You know that you're not getting 0. Identify the coefficients of the x terms and the y terms separately and determine if they were, think of them as common denominators like you used to in the past, or at least common multiples. Which one's easier to find? In this case, I saw 6 and 2, and I knew they can both become 6. How? By multiplying this negative 2 by a negative 3, I would get a positive 6. To go with this negative 6 is how I would get that 0. Now, because I had to change this term, I had to change the whole equation and write down my new equation here. So now I'm not using these two, and you're using these two equations in your problem. And once you find one variable, you plug it back into one of the other ones to find the second variable. All right, let's take a look at an example that involves a little bit more of a complex problem-solving strategy. By complex, I mean it's going to require a couple more steps. Right, so we're trying to solve this and by elimination method, and by trying to see if we get 0, it's kind of hard to see what's lining up. Everything's mixed up, your x terms are not lining up, your y terms are not together, so that clearly shows that they're not in standard form. So really quick, what does standard form look like? And standard form just means that you have your x terms, then it's your y terms, equaling your constants, or your numbers. So if they don't look in standard form, to do the elimination step, we have to have them that way. So I'm going to take each one individually, and I'm going to have to fix them both, rearrange them into standard form. Once they're in standard form, then we will put them back together and make a system of equations and work on it. So in this case, when you're doing this, all you want to make sure you do is your numbers stay on the right and your variable terms stay on the left. So that means out of 1, 2, 3 terms, this number term should be on this side and this y term should be on the left side. Okay? So if this negative 6 shouldn't be there, I'm going to have to add to both sides. And I would like to rewrite what's left to make sure everything is clear. Then I have 4y plus 6. All right, now the 6 is in the right place. The other one we said was in the wrong place was this 4y. Okay, this 4y needs to be on this side with the x term. So it's going to be a subtraction of 4y on both sides. And now on this side I'm left with 2x minus 4y equals 6. So this is gone. Now it's in standard form. Now let's fix the right one. I'm supposed to only have 9 over here because that's the number term, but this x term should be on this side. X's and y's on the left. So all I got to do for that one is take this 3x to the other side by getting rid of it over here and adding it over here. And now my equation is going to be, squeeze it in here, 7y plus 3x equals 9. All right, so now I have two equations in standard form, putting them back together. 2x minus 4y equals 6. Actually, this one needs to be fixed, I'm sorry. We need the x term to be first, so just switch them around. Okay, now it's in standard form. And so now that means now I have 3x plus 7y equals 9. Okay, so now that's my equations I'm going to be working on. And I want to use the elimination method and try to get a 0. Looking at 2 and 3, the least common multiple would be 6. Looking at 4 and 7, the least common multiple would be 28. So if I'm going to try to get a 0, I'll do these two. And it doesn't really matter which ones you choose to make 0. Sometimes it's easier if you choose one specific way, but in this case, we're just going to wish we had a 0 here. And in order for that 0 to happen, I need this to be a 6x minus 6x. Right? I wish that was 6x take away 6x. If it was, I'd have my 0. So now that I made my wish, I got to make that wish come true by changing the equations. So, equation number 1, equation number 2, equation number 1, equation number 2. So in equation number 1, how did this 2x become 6x? It got to be multiplied by 3. 3, 3. All right? And then how did this 3x in the second equation become negative 6x? That one had to be multiplied by negative 2. So everything else gets multiplied by negative 2. Okay? So that same equation has to be changed. If you change one term, you got to change it all. So now let's go ahead and write the rest of it in. 2 times 3 is that 6x. Negative 4 times 3 makes negative 12y. And 6 times 3 is 18. And now that 3 times negative 2 gives me negative 6. So 7 times negative 2 gives me negative 14. And 9 times negative 2 is negative 18. So now when I add these up, that gives me 0. This gives me negative 26y. And this gives me 0. Divided by negative 26. Y equals 0. So that is my coordinate, my y coordinate. And just like before, now that I have y equal to 0, I can use that in an equation. Doesn't matter which one. I always choose the first one. I can go way up here if I want, as long as I use one of the equations in my problem. So I'll just go with this one. And it says 2x minus 4y equals 6. So I'm going to write 2x minus 4y equals 6. Now, because this y is not really y anymore, I do know that it equals to 0. I'm going to put a 0 here. Doing that eliminates the y from the equation, so I can focus on finding x. So now I end up with 2x minus nothing equals 6. Divide by 2, and I get x equals 3. So 3, 0 was a solution. All right, and there you go. Changing an equation, two equations that are not in standard form, into standard form, so that you can line up your terms. And then once they're lined up, you notice that sometimes you do have to change both, but it's just extra time, nothing more difficult.